Okay, here's a follow-up, a second video for that first example that I did with the FBD, because I think we ought to be able to do the cross-product stuff that we might be, maybe that's the stuff that you remember better from statics. I really believe having three views in making FBDs of the thing is superior, but I think it's knowing the cross-product stuff is important too. So I think I might have changed my notes at some point, and I took this small little section out, probably trying to make room for other things, as this first day of class is just jam-packed. So, but I'm going to do this on a separate piece of paper here. And so we did this in the previous video. If you haven't watched that yet, please go back and take a look at that. But what we ended up doing is getting the reaction forces and moments onto this little stump right here. But let's do this, and let's get the same result from the same problem by doing the cross product right here, right? So what we need to do is write out what our load is that's going to be on here, right? So we have an applied force that's onto this, and writing it out as a vector, we see that it's a positive x, so 1500 I, and it's a negative y, so I like to put that inside the parentheses. I really like parentheses. If you keep track of that throughout the semester, you can kind of see. I almost think of the parentheses as they're sort of like a little hug. They're hugging the numbers. But anyway, in the z direction, we have a positive 1,000 K, and then these are pounds. And then our position vector, remember the position vector has to go from the place we care about to the place where the forces are located. And for each force, you might have an individual one that you have to do. So you might have to do this multiple times if you have a lot of forces at a bunch of different locations. Here, they're all just one location. So we only need one. And I don't like capital R for this, because I like capital R to be reactions. So let's use lowercase r right here. And I didn't give it any subscripts. I like to give subscripts at times. But anyway, so it goes in the positive 3 direction, positive y, positive x, positive 3. And then it goes 0 in the y, right? And then in the z, it's in positive z, right here. So all positive numbers at positive 5 is the distance. And you remember all of this, and these are inches in this case. Now, if you want to get the reaction moments of something, you'll recall that M is a vector 2, and it's going to be R cross F, right? You got to make sure they get the position crossed first, because what we do with that is we make a 3x3 matrix. Off the top row, we go IJK. On the second row, that's why that one's first, we go with these, right? So 3, 0, and 5. And then the last row, we go the force, right? And that's why we had to be careful about the order in which we do this and the sign conventions. And see, I think that having that negative inside helps me to remember to put it here. And now we take the determinant of this, and that's going to give us our moments. So if you remember to take the determinant of a 3x3 matrix, and boy, aren't you glad you heard that word, right? Determinants and matrices and all that kind of thing. We'll take I first, right? So we take the determinant of this little guy first, right? Maybe I'll write this out just to remind you, right? So we take the determinant of this stuff. It's I and then this bottom corner, which is 0, 5, negative 800. You don't have to do this step. Most people get kind of used to this and can kind of remember this. Now, this guy always messes me up, but remember there's got to be a minus in that next one. Right, the second one where you're doing a 3x3, it's just the rules, right? Now we're going to take the J, and we're going to have this column and that column right there. So it's going to go 3 and 5 and 1500 and 1000, and that's times J. And then lastly, this one's plus. That was the only minus one, right? There's plus here, there's minus, and then there's plus, right? And then we take this bottom left-hand corner right here. So that's a 3, 0, 1500, and negative 800. And that's times K. And then we did the determinant of each of these. This is not difficult to do because we have 0 times 1,000, so it's 0, right? Minus 5 times minus 800. But it was minus right here, right? That was minus 800, minus 800, minus minus. We're going to get at the end here, if we want to jump to that, we could say we get a positive 4,000 I. Up here, let's do this one. We're going to have a minus bracket and go 3 times 1,000. Minus 5 times 1,500. And that's going to be J. Well, right here, if we take, this is going to be 7,500. Negative 7,500 minus, well, that's going to be, this is negative, and this is going to be added to 3,000. So inside here is a minus 4,500. Did I do that wrong? No, I did it correctly. All right. So in here is a minus 4,500, but then there's a minus there. So it ends up being positive. And then lastly, we do this guy. So we use plus, and we go 3 times negative 800 minus 0 times 1,500. We don't need to write that out. So this becomes a negative 2,400. So plus negative 2,400, and that's K, and these units are inch pounds. So that's the answer right there. Now, what is that telling us? This is going to be the moment of the forces that were on here that are now transferred over to this stump. Let's take a look at the answer that we got previously right here, right? So, well, first off, let's take a look at what we got from our free body diagram, right? X was, this was X, right? It was torque was 4,000, and we saw that it was clockwise, which would normally be minus, right? But here we got positive. What does that mean? Well, that's because we were getting here is we're getting, this is showing it's counterclockwise, right? This is equal to the moment that's about to stump, right? Because we moved a force that was located here. It's now moved over to there. The act of moving these forces over from this spot over to there created a moment that was causing a twisting moment onto this end, right? And that's really of this thing making a moment onto this. And that's the torque, right? That's the one that's going to cause shear stress, or it's going to a kind of shear stress. We'll see there's another shear stress that we need to worry about. All right, so let's take a look at the Y. Let's take a look at the Y, right? So, and this is actually the more complicated one, right? You remember that about the Y, we had two parts to it. We had 1,000 times 3 and 1,500 times 5, and what we ended up with was a negative. So we said, well, that's good. That means that that's going to clockwise right here. But when we came up to here, I said, well, that's going to be counterclockwise, and therefore positive. Well, look at this. That is positive. It's counterclockwise. So doing the cross product got us the equivalent moment that's about the stump. That's for the stump. That's about the Z axis right there, right? So it's actually going, if it's going to go right-hand rule with our Z coming in this way right here, it's a moment that's coming like this right here. That will cause a compression on A and a tension down here at the other, on the opposite side, right? Because it's coming this way right here. It's acting to push with your fingers rolling to push and squish a stress element that would be right into there, pushing on the face of that stress element, pushing it right onto the thing, right? Would be that moment. All right. And then lastly, about the, what did we forget? Okay, the Z, right? We'll notice that the Z here was telling us it was counterclockwise right here. But remember that I said, did I say about the Z? I just said the wrong thing, didn't I? I meant, because we went to the Y one. Yes. Do I want to go back and fix the video? No, let's leave it in. All right. I was talking about this one right here, right? We were just talking about the Y, and that was the one that was actually going clockwise. Counterclockwise. Remember, right there. Counterclockwise. Boom, boom, boom. That's going to cause, counterclockwise is going to cause a tension onto B right here, and a compression onto that other side, right? Because you're trying to spin it that way with a counterclockwise rotation. And now, lastly, for the Z, now that's the one right there, right? We say Z is going to be counterclockwise right here. But you can see that we drew it here. We drew it in the opposite direction. We drew it as clockwise, right? Looking down at the thing, it looks like a clock turning that way. Or if you want to see, oh, that's the opposite of the direction that I would going in the positive Z. My fingers would be rotating the other way. So it's actually, my thumb is actually pointing that way, and my hand, my fingers are now curling around the correct way to go there. And that right there is going to cause a tension at A and a compression down here. So I had said that backwards. Sorry about that. But once again, notice this is negative, telling us that it is a clockwise. So we got the right thing, doing it either way. Doing it this way right here, which is with 3 different views and just taking one at a time and taking the moments and looking at them, or going ahead and doing the cross product. I really think this is a superior way to do this right here, because when you have much more complicated thing, and you're going to analyze it by hand, this is a good way to like visualize what's taking place instead of just looking at the stump, right? Usually want the part. Easier to like think your way through the thing. And then when you're done, it's only just one extra step just to reverse all of the directions onto the thing. When you're doing the stress, I mean, you'll get to the point where you don't need to do that because you've gone through it so many times that you can understand. You could visualize which way the moments are going on here, and you'll get the same result. Right? If you're going to do it by way of a computer, right, or you're going to write a code or something like that, this is much better because it's there's no reversing of the things, and it's writing a MATLAB code is much better to use matrices and that type of thing to take care of. So anyway, I'm going to do another example in the next video of a more complicated piece, and thank you. Hopefully this got some things straightened out. Hopefully it'll be useful.